Subscribe my channel and press the bell icon for the latest video updates. Hello everyone, welcome to my channel on Learning Field. Today in this topic, we will learn about the equate potential surface. What is meant by equate potential surface? Isn't it? So, equate potential means what? Equate potential means the surface which has equal potential, isn't it? We can define equate potential surface by the surface at every point of which the potential due to charge distribution, the potential due to charge distribution is the same, is called the equate potential surface. It's called the equate potential surface. Since equate means, already we know, equate potential means which has equal potential, the surface which has equal potential. If we can define clearly that the surface at every point of which the potential due to charge distribution is the same is called the equate potential surface. For example, you can take the example of for a uniform electric fields, the equate potential surface will be, this is the example of equate potential surface for a uniform electric field. You can draw the diagram of electric field lines. First of all, draw a plane surface. After drawing the plane surface, you need to draw the electric field lines. These are the electric field lines. And V1 is, this one is potential, V2, and this one is V3. This one is the equate potential surface for plane. Okay, for plane surface. We can write here plane equate potential surface. I think you have understood about the concept of equate potential surface. Equate potential surface means what? The surface which has equal potential, isn't it? In simple language, we can say the surface which has equal potential. In, if we define like this, the surface at every point of which the potential due to charge distribution is the same is called the equate potential surface. For example, you can take the example of uniform electric fields. These are uniform electric fields, and this one is the potential V1, V2 and V3, and we can name this one as plane equate potential surface. For example, another example you can take, number 2, for an isolated isolated charge. For an isolated charge, you can draw the diagram. Suppose these are spherical lines, that means spherical surface. These are the spherical surface. You can draw it nicely. I am drawing a rough diagram. These are spherical surface, and suppose we need to draw an electric field lines here. Electric field lines, suppose this is the electric field line. These are some electric field lines of E vector. Okay, for an isolated charge, the equate potential surface, it is this point, isn't it? So these are spherical surface. You can name them spherical surface. Spherical surface. I think you have cleared about the concept of equipotential surface. We have taken the example of for a uniform electric fields and for an isolated charge. Uniform electric fields, the equipotential surface is this point, isn't it? The equipotential surface. And for an isolated charge, the equipotential surface it is this point, isn't it? The next topic is the equipotential surface is the locus of points which the potential due to charge distribution is the same. That means the potential due to charge distribution is the same in equipotential surface. It is the locus, isn't it? Is the locus of points which the potential due to charge distribution is the same. This is the definition of equipotential surface. You can note down any one. So there are some points regarding equipotential surface. No work is done in moving a charge from one point to another along an equipotential surface. That means during an equipotential surface, no work is done. No work is done means no energy, isn't it? In a point charge for a given radius, electric potential is the same. In a point charge, suppose this is a point charge, the radius of electric potential is the same. That means the radius of electric potential is the same. If you have understood about the potential, I think. And the equipotential surface are spherical. For a point charge, the equipotential surfaces are spherical for a point charge. And are spherical surface centered on the screen. These are centered on the screen. This is a point charge, isn't it? Another point is equipotential surface is a surface which has equal potential at every point on it. Since we know that equipotential surface means which has equal potential at every point on it. And you can take the example of uniform electric fields also, the equipotential surface, and for electric dipole also the equipotential surface plus q and minus q. These are electric dipoles. Okay. Another point is equipotential surface due to single point charge are concentric sphere having charge at the center. Look here, these are equipotential surface. This is the line of force, and we can name this one as equipotential surface. Due to single point charge are concentric in circle. Concentric means which are circular, isn't it? Concentric sphere we having charge at the center, which has charge at the center.